to use it, and then I came here, and I mean, there were these graphing calculators, and people were doing matrices on them. I was like, holy cow, how do you do a matrices on a calculator? Boy, I wish I had that in college. Because, no, we didn't use this at all for 4 years. And I know I'm old, but, like, true story. They still don't let you use this calculator in college.
What about, like, basic?
You just need to do it. Like, you need to know it.
Yeah, it takes 5 minutes.
All right, so I wanted to look at number 55, so if you can take out your homework. I want to talk about 55, but also just going quickly through 9 through 16. Those were matching problems. Did you have questions with getting them to match without relying on just plugging it into the calculator? Like, that goal was for you to do that mentally.
Can we just go over them to make
Yeah,
sure that
that's what I figured, yeah.
I didn't have a calculator, so I was
Good.
forced to do
Good. So, Brandon, do you have F for number 9?
Can I just say mine in order?
Oh, sure. We can do that, too. We'll just see what Brandon has.
H, C, A, E, D, G, B.
You get a, what is that, 8 out of 8, Brandon? Nice job. Any questions on those 8 problems? Brandon read you the answers. Very good. Virginia. The power. So the difference between 13 and 15, 13 has a power of a fourth, but in front of that power, it's a negative 1/4. So because the negative makes it go down, where 15 is a positive x to the fourth, so that makes it go up. So the power and then the sign in front is a positive or negative. Right.
And I remember one of the graphs, it was half of a fourth of a x to the fourth graph, and then on the other half it was an x to the 3. So I thought that was pretty weird.
Oh, the
Bottom left one.
bottom left one. Yes, you're right. Kind of is like a mix of both of them put together. But it is an x to the fourth graph because it both ends up. So I wanted to talk about 55 just briefly. The directions of 55 said to find all the zeros of the polynomial function, and then it says determine the multiplicity of each zero. Use a graphing calculator to verify your results. So we didn't really need a graphing calculator here unless you wanted to make sure you were.
What's multiplicity?
Well, I'm going to talk about that. Give me like 2 minutes, Brandon.
I'm excited.
So Kate, if I want to find the zeros at 55, we would take out a t. And then, and how would that factor?
T minus 2 squared.
Yeah, so it's t minus 2 times t minus 2. And then because they're both there, it's a perfect square. We could write that as t minus 2 squared. So that first quantity is a perfect square, that's t squared minus 4t plus 4. So our zeros would be t equals 0 from the first t that's pulled out, and then t equals 2 from the second t that's pulled out. What's special about the t equal 2, Chelsea? It's a double root. That's what multiplicity means. Are there multiple values of the same 0? If there are, that number that it repeats would be the multiplicity. So this has a multiplicity of 2 because 2 is a double root. It's repeated twice. If it happened to be something that factored into a perfect cube, and we had t minus 2 cubed, which could happen, we could have a perfect cube, then it would have a multiplicity of 3 if the 2 was repeated 3 times. And then it would be called a triple root. So multiplicity is just the number of times a 0 is repeated. So if it's only there once, then it has a multiplicity of just 1. But because the 2 is squared, there are really 2 of them there. We call it a double root, but the other word for it would be multiplicity. Questions with that? So today we're going to examine how this part affects the graph versus having a single root. So having a single 0 versus having a 0 repeated is going to change the graph. And we're going to try and look at that today.
I feel like at least for like a parabola or something, the double root would be like where the reflected would be like where it flips.
Exactly. So if you just have y equals x squared, that is just a parabola. That 0 is the double root because it kind of flips, reflects, changes directions. So that's going to happen in our graph if we have a double root. So in your packet, I can't remember what page it is. I feel like it's 18, but that might be wrong. I don't know. Is it 18? Yeah. Woo-hoo. So we're going to go through another example together. Pretty much like a homework problem. So we're going to try and take those answers and graph them. And again, my goal is to get you to rely on your mental capabilities as opposed to the program in your calculator. That will graph it beautifully for you, but we can graph it just as well with that one. So first part, find all the zeros algebraically. Part 2, determine the graph's end behavior. We're going to skip part C, but we're going to go to part D and sketch a graph based off of the zeros and the end behavior. And then we'll talk briefly about the max and min. So if you look, first setting it equal to 0. If I'm finding a 0, it needs to equal 0. Libby, what would you pull out to get this to start to factor?
Pull out, 2, or negative 2.
Yeah. Negative 2x
Squared.
squared. Yeah, let's pull it all out. So a negative 2 and an x squared. So we end up with x squared minus 1. And then that could even factor it a little bit further. Brandon?
0 equals negative 2x squared, x plus 1x minus 1.
Right, that's a difference of perfect squares, which I believe number 49 from your homework was a difference of perfect squares. So we said the power should kind of give us an idea as to how many answers you should have. In this case, we have an x-intercept or a 0 at negative 1 and positive 1. And then we pulled out a negative 2x squared. So Brandon, that means x is equal to?
It's plus or minus 0, which is a double root.
Right. Technically plus or minus 0 because we're going to divide by 2, take a square root, but we don't say plus or minus 0. Instead, we say double root. And that dr, instead of writing out double root, you can just put dr behind it. Yes, that's important. If you skip it, you're skipping an answer. So make sure that if it is a double root, you list it as a double root or you write it twice. But you do need to have it a double root versus a single root. So if we just pulled out an x, then you would just have a 0 there. But if we pull out the x squared, then we need a double root with it. Second part, so this is part A. Part B says determine the graph's end behavior. So we get that from the largest power, which is even, and the coefficient in front of that is a negative 2, so that negative makes it go down instead of going up. So 2 things to look at with end behavior. Even power versus odd power, negative versus being positive. So when it's an even power and it's negative, Michael, what happens with the end behavior of the graph?
As x goes to infinity and negative infinity, y also goes to negative infinity.
Excellent. So he said as x goes to negative infinity and positive infinity, y goes to negative infinity both times. Because they both do the same thing when it's even. They either go up or they go down. They don't split. That's the odd graph that splits. So you have a nice looking graph. Mine is like lighter than light up here. Really see it. And I'm standing next to it. So I'm going to make my own little tick marks on here. We are going to plot the x-intercepts. We're going to graph the end behavior. And then we're going to see if we can connect points to try and finish the graph without relying on the calculator. So 0, there's a point there. A point at negative 1, a point at positive 1. And then the end behavior, Michael said both y values go to negative infinity. So at the end of the graph, I'm going to draw little arrows so that I know where it needs to end. They both need to end down. That's the end behavior. We're going to try and create the middle of the graph now using just the information from the zeros. So when you have a 0, that is a single 0, a single x-intercept because it's just listed the graph will cross through the x-axis, through that x-intercept. So literally it goes right through it. So I'm going to start on my left side, work the way from to the right. Starting with the end behavior that was pointed down, I'm going to play connect the dots. So because it's a single root, that was supposed to go through it, mine didn't, make yours go through. So single root means it goes through the x-intercept and then it goes to a certain maximum value. I don't know what that is. There's no way for us to figure it out without relying on technology, which right now we're not going to refer to. So,
Figure it out later on in our math career.
exactly, next year. But what I do know is if I'm playing connect the dots, there aren't any other dots above, so it has to come back down and connect to the next x-intercept. So I'm going to make it have a max and come back down. The next x-intercept is a double root, and that's what Brandon, I think, was saying, that it should kind of touch that and then pretty much change directions and go in the other way. So right now it's decreasing. Once it hits that double root, it's going to move and become increasing. The double root is either the max or the min of your graph, and in this case it would be a min. So it's going to change directions, and now it's going to move up again. So again, playing connect the dots, we have to go back down in order to get to my next intercept, and that last intercept is a single root, so it's going to go straight through it and then continue down, because there aren't any other x-intercepts to connect. So now I graph without a calculator. Just plain connect the dots, essentially. Questions? So you don't have to get out your calculator, because I don't think, I don't know if any of you have it on your desk. Michael may. No harm, no foul. He has it there for comfort. I just want to show you, just to remind you what you're looking for if you were finding a max or a min. So here's the graph. I just went to y equals, plugged in the graph for the equation, hit graph. This looks close to what we have, except we can't really see that M part happening. So if you zoom in, sometimes zooming in helps see the middle of the graph, because that's the part we're focusing on. There's my M that we just created. How do you find the max? Using the calculator. Chelsea?
The second trace.
Yeah, so second trace, the max is right here, so we would hit number 4. There are 2 of them, so you need to make sure you focus on finding one and then finding the other. That might be good enough. Make sure. So to be on the left side of the peak, be on the right side of the peak, hit enter, and it says my maximum is at -0.707. This is symmetrical. It looks like it has y-axis symmetry. So this point here is also going to be positive 0.707. So we'll list these here because it does ask for the max and min. So our max happens at -0.707 and positive 0.5, positive 0.707, and positive 0.5. Where's the minimum? Just by looking.
0, 0.
Yeah, 0, 0. Because that was the x-intercept, that was a double root. So that's the minimum value. Questions? So we're going to do another one of those in a minute. But we're going to kind of switch directions just slightly and look at a different type of application. And this one wants us to find a polynomial, which is a function, that has the given zeros of 0, 2, and 5. And then it says to multiply the polynomial out. So we now know the zeros. We're trying to create the equation. How would zeros help you create an equation? Brandon knows. So think about, like, how could you use the zeros to come up with an equation? Virginia, what do you think? So we can use them as x and y points, and in this case, they're x points. So x would be 0, x would be 2, x would be 5. How can we expand that, Virginia? Do you know, like, how we could take that to the next step then to try and create an equation with it? So think about what you do to find x-intercepts. What do we do to find x-intercepts? It's my favorite F word. if I have x-intercepts, can we create them as factors? Well, sure. I can create this as a factor by moving it next to x, making it x minus 2. Now it's a factor. If you have a factor, that's how you get an x-intercept. If I have an x-intercept, I can bump it back into factored form. X equals 5 would be x minus 5. X equals 0, Brandon, would just be x, because you wouldn't write x minus 0. That doesn't make any sense. You would just have an x here. We want a function, so I'll put it equal to f of x, and then it says to multiply it out. So to go back to like the original form that this would be in, FOIL, so x squared minus 7x plus 10, and then distribute. We always suggest multiplying the binomials together and then distributing that single term through the problem. So x cubed minus 7x squared plus 10x. If they said the 0 was a double root, it would be x squared. Or if they said your answer should be a polynomial that is a fourth power, then you could throw in that x squared to make it a fourth power. So that could be like something they might tell you in the problem. Or you would just have a written place. Question. So I'd like you to start this next problem. You have 3 or 4 homework problems that are like this. That's why I handed out the graph paper. Maybe you picked it up. You picked it up when you came in, hopefully. If not, we'll make sure to get you one. So you're going to find the intercepts. You're going to find the end behavior. I want you to try and graph it on your own. The last thing is just to kind of check the max and the min values. So see if you can get all of the intercepts. And it says t to the 5th. I just pulled out a t because that was the easy part. So see if you can get it to a factor with that t to the 4th. Just think about what that t to the 4th means. How does that affect your factors? So Libby, when you factor that t to the 4th minus 6t squared plus 9, that actually becomes?
T squared minus 3, and then you can do squared or right.
Or you can write it again. Yeah. So this 9 breaks down as negative 3 and negative 3. But because it starts as t to the 4th, that piece right there, you can't have t times t, because t times t makes t squared. So we need t squared times t squared to get t to the 4th. And as Libby said, the other way you could write that would be t squared minus 3, because that's the quantity that's doubled. You can write the little squared on the outside, but the inside part doesn't change. So one solution is just t equals 0. That's not a double root because it was just t. So no double root necessary there, just t equals 0. The other solution, if you take the 3 to the other side, because we're now solving it by setting it equal to 0, take the square root of both sides, you end up with plus or minus square root of 3. But what's special about that plus or minus square root of 3? Chelsea? They're each double roots because it was squared, so that means there were 2 of those quantities. So you either solve for those quantities individually, or you kind of have to recognize that it's a double root. So the square root of 3 is a double root. Negative square root of 3 is a double root. So here's 2, 4, 5 answers to the 5 power that it was. So we got those 5 powers, 5 solutions. Questions? What's the end behavior? That was the next part, since we're skipping over the max and min. So Jenna, if we have positive and odd, where does that graph end? Yeah, so negative, positive. So if we were writing that out, we would say x on the left side, y is negative. X on the right side, y is positive. Now we can see we can plot the points, play a little bit of connect the dots. So we have a value at 0. Anybody know what, like, roughly the square root of 3 is? A little bit of guesstimating. You know it's going to be less than what? 2. Okay. It's 1.73. It's okay if you don't have it memorized. Totally not required. But you just need to know that it's less than 2. So we have the square root of 3, which is a little less than 2. We have negative square root of 3, a little less than negative 2. Just a little bit of guesstimating. I mean, it doesn't have to be exact when you only have a little spot in between to fill in. Now we're playing connect the dots. So starting with the end behavior, this left side has to work its way up. It's a double root at negative square root of 3. So it's going to touch it and now curve down. It can't go through it. So double root at the negative square root of 3 means it's a max in this case. So now we have to make it go down to some place. I don't know how far. But after it goes down to a certain point, it has to start curving back up. X equals 0 is what kind of intercept? Double or single? Single. So it goes through it. Again, it gets to a max, has to work its way back down to the x-intercept. Now I'm at positive square root of 3, which is double. So it touches it, and then it has to finish back up. Remember, you got to connect the dots up there. It has to finish up high. So it can't go through that because there isn't an end behavior ending down. It's ending up. Questions? See, that was kind of fun not using the calculator. At least in my mind. Probably not all of yours, but hey. It's all right. Questions? So you could look up the max and the min in the calculator. We would have 1 at negative square root of 3, 1 at negative square root of 3, and then we'd have these other 2 that we would have to calculate with the calculator.
This is all intercepts. Does it want the y-intercept?
Well, we would have 1. Yeah, I guess it does say all. It doesn't just say x. So yes, we would have 1 at 0, 0, an x-intercept and a y-intercept. But we have those 4 terms. So it's 5 x-intercepts, 4 terms, 2, 3, 4. Questions? Okay, so your homework tonight. Again, very specific directions that are on the assignment sheet, set to remind, also on the board. Please make sure you're finding that because like the 103, 105 says to use the calculator to get the zeros. Please do them algebraically, factor them out. But those 4 problems that are on there are the 4 problems that you'll find all of the information for. So the end behavior of the zeros, sketch the graph. Lastly, refer to the calculator for the maximum. And then the other page, page 21 in your packet, that's not due until Tuesday. It's in your packet. It's another application problem due on Tuesday. So you have some time to work on that. Questions? Tomorrow we're going to wrap up because I think there is one final example talking about intermediate value theorem. So we'll wrap it up tomorrow. Any questions before you quit? Quiz should be easy. The book is open. When you're done with your quiz, feel free to take a picture of it. You can get started on that homework. When you turn in your quiz, you can take a snapshot of the book. Somebody telling you don't think you'll need it.
I'm gonna check.
You can use a calculator if you feel like it makes you feel better to have it on your desk. I really don't think you'll need it.